So we were talking about the application of the Bernoulli equation. So if I just apply the second law of Newton on my fluid element, I write sum of forces equal ma, and I do the development. I will not go through the development because you are not responsible for derivation. I just want you to understand the final result. Okay, your final result is the following. If I have steady incompressible flow, I can write the following relation, that P over rho, the pressure of my fluid over rho, plus V square over 2, V is the velocity, plus Gz equal to constant along a streamline. So the condition first, so keep in mind these conditions, steady, incompressible. I should take points, 2 points on the streamline. So if I follow a particle, if I take a picture of my domain, I can see and I have my velocity vectors. If I join my velocity vectors, I get a streamline. So it should be, the points should be along the streamline. And the additional condition is that I don't have losses. No losses due to viscous effects or due to any heat or any heat loss, anything else. No losses. Okay. Then I can say that I have that this summation is constant. And what does this mean physically? Physically, P over rho, this term is related to the energy of the flow, my flow energy. V square over 2 is related to the kinetic energy of my flow, and Gz is related to the potential energy of my flow. So if you want, Bernoulli equation is simply like conservation of mechanical energy in a solid. It's the conservation of energy for a flow. Okay, so it states that the summation of kinetic, potential, and flow energies of a fluid particle is constant along a streamline during steady flow when compressibility and frictional effect can be neglected. Okay, now we can put the Bernoulli equations in several forms. Okay, we can put it in this way, or if you multiply by rho, you will get that P plus rho V square over 2 plus rho Gz equal to constant. So as we said, the terms, the P over rho represents the flow energy, V square over 2 related to kinetic energy, and Gz related to potential energy. And if I multiply by rho, I will get the following result. P plus rho V square over 2 plus rho Gz equal constant. Now, as you can see here, all your terms have as dimension the dimension of pressure. So physically, we say that the first term P is the static pressure. What do I mean by this? It is the pressure of the flow. And it does not incorporate any dynamic effect. So if it's moving or at rest, if I take a device and measure the pressure, okay, it's independent. So the static pressure is will not consider if my fluid is in motion or at rest. It's just related to the energy of my flow. Okay, so this is the pressure we use in thermodynamics tables. Now, rho v square over 2, okay, this term is related to fluid motion. And this is why we call it dynamic pressure. What does this mean? It means that it represents the pressure rise if the fluid in motion is brought to a stop isentropically. What do we mean by this? Look, we say we have conservation of energy, yes or not? So especially if I bring it to if I have a fluid in motion and I bring it to a stop isentropically. When I say isentropically, this means without losses. If I am doing this, I can apply Bernoulli equation. Okay, and what will happen in this case? This term will be converted into what? Into a pressure term. Because look, if I am moving on a straight level, so potential energy is not varying. Okay, what if I decrease the velocity? What will happen? The kinetic energy will be transformed into another type of energy, which is related to what? related to pressure energy. Okay, this is why we say that if I rho v square over 2 will represent the increase in pressure if I force my fluid to stop in an isentropic way without losses. So if I force it to stop, I should increase its pressure because energy should be transformed. Energy is conserved. It will be transformed from kinetic to pressure energy, flow energy. So this is why we say that rho v square over 2 is called dynamic pressure. Okay, and we have a term called stagnation pressure. The stagnation pressure represents the pressure of my flow if it's when it will stop. So the stagnation pressure will be equal to the static pressure, okay, P static plus the dynamic pressure, which is rho v square over 2, okay, plus dynamic, okay. And I repeat, what are the conditions? I am stopping it without losses, so isentropically, and moving at constant horizontal level because I don't have change in potential energy. Okay, so it's P static plus P dynamic. Okay. Okay. So now rho GZ is related to what? This is the hydrostatic pressure. It's related to potential energy. Okay, so it's not a pressure in a real sense since its value depends on the reference level selected and it accounts for the elevation effect. Okay, now the total pressure is the summation of static, dynamic, and hydrostatic pressure. And since we are dealing with a case with no losses, we are applying Bernoulli, we can say that the total pressure is conserved. So if we have exchange, we will have exchange of pressure or of energy between potential, kinetic, and flow energy. Okay. Now we will see how this equation will help us in understanding hydropower. So here it's a summary again of the Bernoulli equation. We have these conditions. First, it's a steady flow, no transient effects. Second, it's a frictionless flow, so no friction, no heat loss, no loss by viscous effects. Third, no shaft work. So Bernoulli, we cannot apply it for a turbine, for example. If I have a turbine, if I have a compressor, I use what? I use the first law of thermodynamics. I include the work, the heat rate, and the variation of energy. So for Bernoulli, no shaft work because Bernoulli equation is not applicable in a flow section that involves a pump, a turbine, a fan, or any other machine since such devices destroy the streamlines and carry out energy interactions with the fluid particles. So I should have streamlines. This is why I said, no, I am applying over a streamline, a certain smooth line that I can follow. I should not have disorder. I should not have turbulence. Okay. Now, for incompressible flow, the density in general, يعني, we can apply sometimes Bernoulli for flow with variable compressibility, but the variation of compressibility should be very small. Okay, so density can be considered constant even for a gas, but the condition is that Mach number is less than 0.3. Okay, which is the Mach number is the ratio of the flow velocity over the speed of sound. So the fifth condition is I don't have heat transfer because I don't allow losses. This is why I should not have heat transfer. And finally, I should have a flow along a streamline. So strictly speaking, the Bernoulli equation is applicable along a streamline. Okay. However, when a region of the flow is irrotational and there is a negligible small vorticity in the flow field, the Bernoulli equation becomes applicable also across the streamline as well. So as I told you, nearly I should be, it's fine, I should be in a laminar zone, but not with high viscous effect. So I should be close to the turbulent zone, but not to have high turbulence, because high turbulence will destroy my streamlines. Okay, so if you want, Bernoulli is just applicable at the limit. So I have a high Reynolds number, but still not disorder and no losses due to turbulence effects. Now, let us apply here. Here, this example will let us understand how Bernoulli will help us into understanding hydropower, how energy is converted in hydropower numerically in an equation. So, for example, if I give this simple example, I have a large tank, okay, and I want to discharge water from this tank to the atmosphere through the open jet at section 2. So in this case, what will happen is as I will apply Bernoulli equation between state 1 and 2, because here you can say that I am far from the walls. I have, if I look at my water, I can, if I look here, for example, if I take a picture, I can, and I join my velocity vectors, I can see this, that I have my fluid moving along the following streamline. Okay, so I can apply Bernoulli equation between point 1 and point 2. Okay, so now if I apply Bernoulli, it will tell me that P1 over rho g plus V1 square over 2g plus Z1 equals to P2 over rho g plus V2 square over 2g plus Z2. Okay, now let us do analysis of the terms one by one. First, my tank is open to the atmosphere, so pressure at point 1 is equal to atmospherical pressure. So P1 is PA. But also, okay, also my discharge level, at the exit level, my jet is exiting to the atmosphere. So also the pressure at point 2 is equal to PA. So what I can say that I can here, these two terms are equal, P1 and P2 are equal, so they will simplify. Okay. Now, you know that mass here is conserved. Okay. So what is going out here, because of velocity, water level drop here, velocity will go, the water will go out. Okay. So from conservation of mass, I can write that m dot at level 1 is equal to m dot at level 2. So what is the level of water that is dropping is equal to the level of water that is getting out. Now for m dot 1, I can say it's equal to rho of my water times area of my tank. Okay, the cross-sectional area of my tank, I will call it AT. Okay, times velocity V1 at the level of where my water will drop, equals to rho times the cross-sectional area A2 of the jet exit times V2. Okay, but look, first rho can be simplified, so I will simplify rho. Now as you can see here, the cross-sectional area of your tank here, which is corresponding to the circle, is much larger than the exit hole. Okay, so you can say that A tank is much larger than A2. So I can say that V1 is much smaller than V2. This is why I can, compared to V2, I can say that V1 is nearly 0. And because it's very small, I will cancel out this term. And what I can deduce? I can deduce that now for Z I need a reference. You can take the reference wherever you want. Why? Because what you care at the end about is the variation in Z. So wherever is your reference, delta Z will be the same. Okay? So for example, if you choose this level to be 0 for Z, if this is 0 for Z, then Z1 will be 0 and Z2 will be plus 5. Sorry, if you choose this is 0 level, Z2 will be 0 and Z1 will be plus 5. Okay? And delta Z will be minus 5. And if you choose your 0 above, you will obtain the same result. Because if you choose your 0 above, then Z1 is 0 and Z2 is minus 5. So if you do delta Z, what will be delta Z? So delta Z will be equal to minus 5. So wherever your reference is, you will get same delta Z. Because if I choose 0 reference at low level, I have Z2 equals 0, but Z1 equal to 5. So if I do again delta Z, I will still obtain minus 5. This is why we say that you can take the reference wherever you want. It will not affect your result because it will affect the values of Z but not delta Z. Okay? So here, wherever the reference you take, you will end up with the following result. That Z1 minus Z2, so Z1 minus Z2 is equal to V square, V2 square over 2G. And what does this equation mean? This simple application of Bernoulli will show me that higher is Z1, higher will be my discharge velocity. This means that the potential energy here is transformed into kinetic energy. So here it's a simple application where potential energy is transformed into potential energy, into kinetic energy, sorry. And this is the concept of water dams and hydropower, as simple as that. Okay, because in water dams I will store water at very high level. I will so I will store energy in form of potential, and whenever I want to use this energy I can open let's say a small hole and water will flow. The potential energy will transform into kinetic energy that can be used to rotate the blades of the turbine and then produce electricity. So here potential energy is transformed into kinetic energy. So you can see here how Bernoulli equation will simply tell you what is taking place in your application. How I can convert one form of energy to another form. So what is hydropower? Hydropower refers to energy, mostly electrical, which is derived from water in motion. This power is harnessed and used to drive mechanical devices. The main advantage of this form of energy is that it is clean and renewable. So here, no pollution, no bad effects as in the case of fossil fuels. Hydropower plants are actually based on a simple concept, which is the one we did together now. We derived from Bernoulli equation that we can convert potential energy into kinetic energy, and then this kinetic energy of water will flow through a dam that turns a turbine, which will turn a generator, producing therefore electricity. So this is the simple concept of hydropower. And hydropower is one of the most important renewable energy sources because you know that water is widely available, it's renewable, and it will not using water will not lead to pollution and will have so no harmful effect on the environment. And it uses the single but very powerful energy force of moving water. By some comparison, it competes with the energy produced by fossil fuels and nuclear power, but is considered much cleaner and more simple. Hydropower remains popular even in third world countries which do not have the resources to build expensive nuclear generating stations. So hydropower does not pollute the atmosphere or environment, and it is a practical way. So even for countries under development, it can be used. In the following figure, we have the figure of a hydroelectric plant, and it will illustrate how it will work. So here, for example, you can see we construct a dam. So this is our dam here, okay? And then what we do is we can have here a certain valve that can open or close the passage of water. So when we don't want electricity, we close it, and water is stored here in the dam. So it will store energy in form of potential energy. Higher the level of water is compared to the turbine level, higher will be the potential energy. And therefore, whenever you open your valve here, water will flow from 1 to 3 through 2, okay? And in this case, potential energy is converted into kinetic energy using the same relation we developed to gather from the simple example of the tank. And therefore, I can produce a flow of high kinetic energy reaching my turbine. Once at contact with my turbine, I will transform this kinetic energy. As we have seen in the introduction chapter, I can transform the kinetic energy into mechanical energy of rotation. Okay, so I will rotate the blades of my turbine, and the turbine in turn will rotate the axis of the shaft of a generator, which will lead to production of electricity. Okay. So here in summary, you have step one in the reservoir of water. Behind the dam, we pushes forward at high pressure water. Once we want to use it, we have a turbine passage where when opened, water will flow over it until reaching the turbine. At level 3, we have the turbine, which are similar to big propellers, and they are placed in the middle of each water passage. The rushing water will spin the propellers, which will turn the shafts and the generators, which will produce electricity. The generator produces the electricity, and each generator is connected by a drive shaft to a turbine. And finally, water should be exhausted. So here you have the outlet from here. It can go back to the river. Any question on this? Now, hydropower uses the energy of moving water for a variety of useful applications. Hydroelectricity generates electricity by harnessing the gravitational force of falling water and therefore transforming it into kinetic energy, then into mechanical energy of rotation, then into electrical energy. In 2006, hydroelectricity supplied around 20% of the world's electricity, which is a very good percentage, and it's rising. Most hydroelectric power stations use water held in dams to drive turbines and generators, which turn mechanical energy into electrical energy. The largest hydroelectric power station in the world is in China. So here again, this is another figure showing you the system. So same concept, same, if you want, elements. Just here you can see, in addition to the previous figure, you can see how your generator is connected to the power lines. So your generator can be connected to electricity grid in order to transport electricity to the cities that are in general far from dams, because we will see that dams present high risks also. So when we do the construction, we should pay attention to have them far from areas where we have population. And this is a figure of a real dam. So as you can see here, you have the flow of your water from a very high level that will lead to a very high kinetic energy. Now, the advantage of dams Once a dam is constructed, electricity can be produced at a constant rate. So it's a constant source of electricity. If electricity is not needed, the gate can be shut, stopping electricity generation. So as we said, in this case, we will store energy in the form of potential until we need it. So the water can be saved for use another time when electricity demand is high. Third, dams are designed to last many decades and so can contribute to the generation of electricity for many years. So these projects have a very long lifetime. Okay, so this is why they are important and they are nice to do. And we will study in the final chapter in this course, we will see how to study the project on the economical level. So we will do life cycle cost assessment to see if it's a project that will be of profit or not. And fourth, the lake that forms behind the dam can be used for water sports and pleasure activities, and often large dams becomes tourist attraction in their own right. So even on the economical level, it can help the country because it becomes a touristic attraction for people. And finally, the lake's water can be used for irrigation purposes. So as you can see here, after you use water, water will flow from the dam, but water you will not lose it. You can use it again because it will be exited to the river, and then you can use this water for irrigation purpose or for any application needing water. Now, concerning the disadvantages of dams, first, dams are extremely expensive to build and must be built to a very high standard. So first, because they are very huge and we need to do a lot of safety factors, the cost is very high. Okay, and because they can cause uh, catastrophic results if we have rupture. This is why we need to build them using very high standard, which will increase their cost. So the high cost of dam construction means that they must operate for many decades. Why? Because we need to get back the money. So this is why, in general, they operate for a very long lifetime to be able to become profitable. Okay, and one of their good things is they can still work for very long time. Okay, now the third disadvantage is that the flooding they can cause the flooding of large areas of land. uh, so in this case natural environment will be destroyed, and we had a lot of accidents in the world due to that. Fourth, people living in villages and towns that are in the valley to be flooded must move out. So this means that they lose their farms and businesses. And in many countries, people are forced to change their places because of building of hydropower schemes. And fifth, the building of large dams can cause serious geological damage. So, for example, the building of the Hoover Dam in the USA caused a number of earthquakes and has depressed the Earth's surface at its location. So, this is the chapter on hydropower. So, today we did two chapters because they are very simple. Okay, so now from now on, we will have shorter chapters. The heavy chapters were at the beginning,
Doctor,
chapters 2 and 3, and from now on it will be this style. Yes,
there are no questions or on this chapter.
I will give you problems, yes, but they will be if you want. These chapters are like different approach than the first two chapters. For the first two chapters, I want you to understand well the concepts and how energy is transferred in numbers. But for these chapters, just you should understand concepts. You should need to do qualitative comparison, and I will propose some problems, but they will be easy. Because you don't have to go deep in calculations here in this chapter.
Okay, thank you.
Okay, welcome. So hopefully we will meet Saturday. And if you have any question for the exam, I'm ready anytime you want. You can send me WhatsApp. We can organize office hours whenever you want if you need help. Okay?
Doctor, I have a question.
Yes.
Sorry. In the problem set of chapter 2, there's a place when we mentioned the HSS sky. You remember when we had this, when
Yes.
we had the roof and the
Yes.
formulas for HSS sky and
They will be given.
emissivity. اوكي لانه ما كنت عم بعرف وين اجوا. I thought
They
انه
are
we solved
given in
something
the
for
problem.
them.
They are given in the or in the previous problem. If you look
Okay,
at the
we are only
previous
response. Sorry.
yes,
Yes,
you
sir.
are not responsible to remember any formula. I will give you if I give you something similar, because it's open book, you can directly use them. But if I give
Yes,
you
yes.
any new application, I will give you the empirical relations.
Okay, okay. Thank you, doctor.
Just a question. Did you say anything about the midterm or the paper in the beginning of the
Concerning
class?
the midterm will be divided into two types of questions. You have questions testing your understanding of concepts. So it will be qualitative question, MCQ. It will be on the introduction chapter and chapter 2 and 3. Okay, but if I gave you an example last time. For example, conduction is a heat mode mainly in what? Solids, gases, or liquids. It's mainly conduction takes place mainly in, it's dominant in solids, for example. So such type of questions to see if you understand the concept. Okay. The second type of questions you will have is small problems. Small problems similar to what we did together in chapters 2 and 3. Okay, you will not have longer questions because you have several small problems to solve.
And is it feasible if to do it in 1 hour, like to revise our work and everything? Or
Look, to be honest with you,
on time?
because it's an online exam, always the strategy is to give a short time. Okay, but please don't panic if you don't finish. I will tell you why. Because the short time is done because in a way that you cannot go back to your slides. So you should understand the material in a way not to need to go back to the slides to know the answer. So for online exams, we give a short time, but I am aware of the short time. So maybe the highest grade will be 80 or 90. Okay, so even if you don't finish, I will do a raise after. So the exam is done to not be finished. Okay, so don't panic if you don't finish. But what you do it good and take your time. Of course, don't take a lot of time, but just take the time to do it well. And if you feel that you don't know a question, directly skip it. You don't have backtracking. You cannot go back, so you cannot revise. Okay, this is done to avoid cheating effects. So please, if you feel that the question is hard for you, skip it. Just skip it.
And when will you post the solution to the assignment of chapter 3?
Yeah, now I will do it today.
Okay, thank you.
Okay, welcome. Any other question?
Thank you, doctor.
So good luck for the exam. And again, if you need any help, tell me. I'm ready.
Doctor, I have
Yeah?
a question about the exam.
Yes.
Do we have to mute ourselves or just put the camera on?
Yes, you should put the camera on. If we have a lot of noise, we can mute.
Okay.
Okay. Yeah. So on Saturday, I will look for the exam. I will send you a WebEx link because for the exam I want to have unlimited time, so it will be on WebEx. Okay. And I will send you the link just before the exam. Just 10 minutes before, so we can join, all of us, we can join and we can start the exam together. Okay, so see you on Saturday. And if you need anything, we can do office hours, or you can send me your questions by WhatsApp whenever you want.
Miss, it's on بالعادة ما هيك.
Yeah,
It's on Moodle.
the quiz is on Moodle, yes. So for problems, numerical problems, it will not be MCQ, it will be numerical answer. So you solve and you input your answer in the box. And for multiple choice, you can have several answers that are right. Okay. So for multiple choice, not only one choice is right, you can have several choices that are right. So pay attention also for this. Okay. Any other question? Okay, bye-bye.